Greetings dear learners, I am faculty of physics at SRN International School, Jagatpura, Jaipur. Today I will cover the second part of alternating current video, which is taken from chapter 7 grade 12 physics. So let's start the video. Today I will cover following topics: AC circuit with resistor, AC circuit with inductor, AC circuit with capacitor, and the combination of all three components, that is AC circuit with series LCR. Now first type of circuit which we are going to study is AC circuit with a pure resistor. Now in this diagram you can see that a resistor is connected with a circuit in which power source is alternating current. EMF is represented as E naught sin omega t, and we will find the value of current, and you know that the value of current is E upon R, that is EMF upon resistance supplied in the circuit. Now with the help of this expression we can find the value of current, that is I is equal to I naught sin omega t. Here with the help of the equation of current and EMF we can obtain that current and EMF are in the same phase. Same phase means if the value of current increases, the value of EMF also increases, and if it decreases, both value decreases. Here in the graph wave diagram we can see that current and EMF both starts from 0, reaches to their peak values at pi by 2 phase angle, and again reaches to 0 at pi phase angle. Similarly the cycle continues. Now if we talk about the phasor diagram, we will find that current and EMF both are at the same phase angle, that is omega t, pointing to the same direction. Let's talk about second type of AC circuit, that is AC circuit with a pure inductor. Now as we know the role of inductor in the circuit, we can check it from the diagram that inductor is like number of coils in a circuit with having an AC power source in it. L is the representation of inductor. Now we know the value of EMF, that is E naught sin omega t. Now to find the value of current in the circuit we will use the expression E is equal to L di upon dt. With the help of this expression we will find the value of current, and then after integration, because we obtained the value of dl, so to find the value of current we will integrate both the sides. After integration we will get I is equal to I naught sin omega t minus pi by 2. So if we compare both the value of current and EMF, we will obtain that current lags behind EMF. It means if the value of current is 0, EMF will be at 90-degree phase angle. So with the help of wave diagram we can obtain the same thing. Current is 90-degree lags behind the EMF, and EMF starts from 0. Now in the phasor diagram we will obtain the same thing, and same thing is what, that if the EMF is pointing at an angle omega t from the horizontal x-axis, the value of current will be 90-degree behind it. So this is the thing which is obtained in AC circuit with pure inductor. Next type of circuit is AC circuit with a capacitor only. This diagram represents the capacitor is connected to a circuit in which AC power source is there. Again we will do the same thing, that is the comparison of EMF and current. EMF is that E is equal to E naught sin omega t. The value of current we will obtain from the expression of the capacitor, that is I is equal to dq upon dt, and q will be taken from the capacitance and EMF, that is q is equal to Ce E is equal to E naught sin omega t, so we will put the value of E here. Now in this expression we have to find the value of current. So dq upon dt is the value of current. So we will differentiate the charge per unit time. So after differentiation we will get the value of current, and current will be equal to I naught sin omega t plus pi by 2. Here in this expression we obtained that current leads with the EMF by pi by 2 radians. Now in the graph we can observe the same thing. When the current is having the peak value, EMF will having the value 0, and with the help of same phase difference, current and EMF will move in the cycle. Now we can obtain the same thing in the phasor diagram. In phasor diagram we can say that EMF is at pi as a phase angle omega t from the horizontal, but the current is 90° ahead from the EMF. So this is the representation of AC circuit with a capacitor. Now the last type of circuit is AC circuit with LCR in series. Now this diagram represents that all three components are attached in the circuit in series with alternating power source. Now we will represent all these voltage in the vector form, and here we can have the voltage across resistor in the horizontal axis, voltage across inductor in the positive y axis, and voltage across capacitor in negative y axis. Now we can see that voltage across inductor is having greater value and the voltage across capacitor is having smaller value. This is because of the pre-assumption that the voltage across inductor is higher to the voltage across capacitor. Now if we assume so, now we can have a particular vector representation of voltage across inductor, capacitor and resistor, and here in the next diagram we can obtain the same thing. So resultant of voltage across LCR is given as under root VR square plus VL minus VC whole square. Now this value of EMF is known to us now. Now value of current will be E upon R. So resistance or opposition to the current in the entire circuit due to LCR will be given as under root R square plus XL minus XC whole square. Here XL is the inductive reactance, that is opposition of current due to inductor, and XC is the capacitive reactance, that is opposition to the current due to capacitor. So now applying the value we can find the value of resultant, angle of resultant with the horizontal, that is tan phi is equal to XL minus XC upon R. Now after getting this value we can find this value in the three different conditions which comes under special cases. Now if the value of XL is greater than XC, that is dominance of inductor in the circuit, so it will be represented like that. In that case the value of tan phi will be positive and the dominance will be of inductives. Second case, if XC is greater than XL, it means that there is a dominance of capacitor in the circuit, so it will be the capacitance dominated circuit. Finally, if the value is same, that is XL is equal to XC, in that condition tan phi will be equal to 0 and the circuit will be purely capacitive circuit. So in the last slide there was the last special case, that is of pure resistor circuit, in which there is the dominance of resistor only because the effect of the inductor circuit and capacitor circuit is neutralized because of equal value. So that's that's all for this short video of alternating current. So thank you all of you. Like this video and subscribe our YouTube channel. Bless you students. Thank you.